Welcome to the vast expanse of the cosmos, where giant worlds rule the void and mysteries await us. This is Dark Sky Dive. From a great distance, Jupiter appears as a single massive planet, striped with storms and dominating the darkness of the solar system. It looks like a single world, unmistakable in its grandeur, a gas giant that has captivated astronomers for hundreds of years. But look much closer, and Jupiter begins to behave less like a simple planet and more like a star system in miniature. Because orbiting this giant are more than 90 confirmed moons, and each one of them is a unique world of its own. Together, they form something truly extraordinary, a mini solar system bound tightly by Jupiter's immense and inescapable gravitational pull. Jupiter is the largest object in our solar system that is not the Sun, a titan among the other planets we know. It contains more than twice the mass of all other planets combined, a true heavyweight champion of our planetary neighborhood. If Jupiter were just 80 times more massive, nuclear fusion would ignite in its core, and it would become a star. It failed to ignite, but not by much, leaving it as a failed star that forever dominates the dark void. That failure left Jupiter with gravity so powerful that it dominates everything around it, creating an empire of gravity and gas. This influence extends to an army of moons, captured and held in place by the invisible hand of this giant world. For centuries, humanity believed Jupiter was alone, known to have only 4 major moons visible through early primitive telescopes. In 1610, Galileo Galilei pointed a telescope at Jupiter and saw something revolutionary that changed our understanding forever. He saw 4 small lights moving around it, dancing in a rhythm that proved not everything orbited the Earth. Io, Europa, Ganymede, and Callisto. These were the first worlds ever discovered orbiting another planet beyond our own Earth. Today, we know Jupiter has over 90 moons, and the number keeps growing as our detection methods continue to improve. Some are tiny, just a few kilometers across, while others are larger than planets, offering a diverse range of celestial bodies. And none of them are boring. Each holds secrets that challenge our understanding of how solar systems are formed. Let's start with the giants. Ganymede is the largest moon in the entire solar system, even bigger than the planet Mercury. It is unique because it has its own magnetic field, a feature usually reserved for planets, not mere moons. It has a layered interior and likely hosts a hidden ocean beneath its icy surface, containing more water than Earth. Europa is smaller, but far more intriguing to scientists searching for life beyond our home planet. Beneath its cracked ice shell lies a global ocean of salty water, possibly twice the volume of Earth's oceans combined. This hidden ocean makes Europa one of the most promising places to look for alien life in our solar system. Io is pure chaos. It is a world of fire and brimstone, contrasting sharply with its icy neighbors. The most volcanically active world we've ever seen, with lava fountains shooting hundreds of kilometers into the sky. Callisto is ancient and battered, a frozen record of the solar system's violent past preserved in ice and rock. These 4 moons alone would be remarkable around a star, yet here they are, orbiting a single planet. But they orbit a planet, and that relationship defines their existence in ways we are only beginning to understand. Jupiter's gravity doesn't just hold moons in place, it shapes them, molding their interiors and surfaces continuously. As moons orbit, they are stretched and squeezed by Jupiter's immense pull, a process scientists call tidal heating. That internal friction generates heat, enough to melt rock and drive the most violent geology in the solar system. It is enough to keep oceans liquid beneath miles of ice, creating potential habitats for life in the dark. Enough to power volcanoes without sunlight. Jupiter isn't just hosting these worlds, it is actively engineering them. Beyond the large moons lies a chaotic swarm. Dozens of small, irregular moons orbit Jupiter at extreme angles. Some even move backward. These moons weren't born around Jupiter. They are strangers caught in a gravitational trap. They were captured. Ancient asteroids and fragments of shattered worlds pulled in by gravity so strong they found no escape. Each one is a relic, a fossil from the early solar system, frozen in orbit for billions of years. Jupiter's dominance extends far beyond its moons. It acts as the gravitational anchor for its entire neighborhood. Its gravity shapes asteroid belts, deflects comets, and alters the orbits of planets throughout the entire solar system. Some scientists believe Jupiter acts as both shield and executioner, playing a dual role in Earth's safety, deflecting some asteroids away from Earth while hurling others inward. Jupiter controls the architecture of our solar system. Its moon system is simply the most visible evidence of that power. When mapped, the resemblance is uncanny. Inner moons orbit quickly, tightly bound. Outer moons drift farther away, slower and more chaotic, just like planets. Even resonance patterns exist, where moons influence each other's orbits in stable, repeating rhythms over vast periods of time. It's not a metaphor. Jupiter's system follows the same gravitational rules as a solar system, just compressed into less space. Why does this matter? Because Jupiter may be a template for understanding star systems across the entire galaxy. In other star systems, astronomers have discovered massive exoplanets orbiting close to their stars, much like our Jupiter. If those planets have moon systems like Jupiter's, they could host dozens of worlds we haven't even considered yet. Oceans, volcanoes, atmospheres, entire ecosystems orbiting planets instead of stars. Life, thriving in places we never thought to look. We once thought planets were simple. One world, one surface, one story. Jupiter shattered that idea completely. It is not a single planet. It is a system. A gravitational empire surrounded by worlds of fire and ice, each shaped by its parent giant. And with every new moon discovered, Jupiter reminds us of a humbling truth. The universe builds on scales we are only beginning to understand. Jupiter doesn't just have moons, it has a population, a miniature solar system locked in eternal motion, spinning around a world that almost became a star itself. And as we continue to explore, one thing becomes clear. If we want to understand how planetary systems are born, how worlds evolve, and where life might exist, we don't always have to look to distant galaxies. We just have to look at Jupiter. It holds the keys to understanding the architecture of our universe. Let's dive deeper into the atmosphere of this failed star. The storms here are unlike anything on Earth. The Great Red Spot alone is a storm that has raged for centuries, large enough to swallow Earth whole. Winds here scream at hundreds of kilometers per hour, tearing through the cloud tops with relentless fury. Lightning bolts pierce the gloom, strikes so powerful they would vaporize a city instantly if they happened here. These clouds are not flat. They are towering mountains of ammonia ice and water vapor, floating in hydrogen. NASA's Juno spacecraft has given us a front-row seat to this violence, revealing the deep roots of these storms. At the poles, we see auroras that never stop. Constant light shows powered by the planet's immense magnetic energy. Unlike Earth's auroras, which are caused by the sun, Jupiter's are fueled by its own rotation and its moons. Volcanoes on Io spew tons of material into space, which Jupiter grabs to paint its poles with electric light. The planet screams in radio waves. If our eyes could see radio, Jupiter would be brighter than the moon. Its magnetic field is the largest structure in the solar system. If visible, it would appear larger than the full moon. Inside this bubble, radiation is intense. It is a death trap for electronics and biology alike. Spacecraft must be built like tanks with heavy shielding to survive even a short visit to this environment. Despite the danger, we are compelled to return. The allure of Europa's hidden ocean is too strong to ignore. Future missions plan to drill through the ice, sending robotic explorers into the alien waters for the first time. What will they find? Perhaps simple microbes clinging to volcanic vents, or maybe something far more complex and strange. Ganymede also beckons. Its magnetic field and own ocean make it a prime candidate for future human colonization. Imagine standing on Ganymede, looking up at Jupiter filling the sky, a view that would define a new era. Callisto might be our safest harbor. Far from the deadly radiation belts, it could be our gateway to the system. With abundant water ice for fuel and a stable surface, Callisto could become the gas station of the outer solar system. Io, however, will likely remain a place to observe from afar, a world too violent for human footsteps. Its surface is a constant construction zone, resurfaced by lava every million years, erasing all history. This system is a dynamic, living laboratory. It teaches us about gravity, magnetism, and the potential for life. In many ways, the solar system is a binary system that failed. The Sun and Jupiter, a pair of unequal partners. They balance the solar system between them. The Sun provides the light, but Jupiter provides the gravitational stability. Early in history, Jupiter may have wandered inward, clearing out debris and paving the way for Earth to form. Without this wandering giant, our solar system might look very different, perhaps with no Earth at all. We owe our existence, in part, to the chaotic history and immense gravity of this gas giant. Yet mysteries remain. We still don't know for sure what lies at the very center of Jupiter. Deep down, hydrogen turns into a metal, a strange state of matter that exists nowhere on Earth naturally. The pressure is immense, millions of times the atmospheric pressure of Earth, crushing everything into a dense soup. We have sent probes to their death to learn this. The Galileo probe survived only minutes before being crushed. But those few minutes gave us invaluable data about the composition of the giant, confirming our theories. Now, new missions like ESA's JUICE are on their way to unlock the secrets of the icy moons, and NASA's Europa Clipper will investigate the ocean moon, looking for conditions suitable for life. The next decades will be the golden age of Jupiter exploration. We are going back, and we are staying. Perhaps one day, it won't just be robots. Humans might witness the great red spot with their own eyes. Until then, we watch from afar, marveling at the beauty and terror of this mini solar system. Jupiter has always captured our imagination. From ancient myths to modern science fiction, it looms large. Named after the king of the gods, it lives up to its title, a ruler of the night sky. It stands guard at the boundary of the inner solar system, a gatekeeper for the rocky worlds like ours. Without a giant like Jupiter to stabilize orbits, Earth might have had a much more chaotic and hostile history. It even has rings. Faint, dusty rings that are invisible from Earth but beautiful when seen up close. These rings are made of dust kicked up by meteor impacts on small moons, another sign of the system's complexity. For physicists, Jupiter is a dream, a natural laboratory to study fluid dynamics without the interference of land. The polar storms arrange themselves in geometric patterns, a puzzle of physics that we are still trying to solve. It floats in the cold dark, 5 times further from the sun than Earth, receiving only faint sunlight. Yet it glows. It emits more heat than it receives from the sun, powered by its slow gravitational contraction. It shrinks by a few centimeters every year. That tiny movement generates enough heat to drive its massive storms. Some call it a failed star, but perhaps it is better to call it the most successful planet. Planet. Rings, moons, magnetosphere. It has everything required to be a system of its own, independent and majestic. Studying Jupiter teaches us humility. It shows us that our world is just one type of many possibilities. It expands our definition of the habitable zone. Life doesn't need a warm Earth. It might just need a warm moon. From the first grainy images of Voyager to the HD views of Juno, our fascination has only grown deeper. We have learned so much, yet we have only scratched the surface of what this giant system holds waiting. The story of Jupiter is far from over. It is a book with many pages still left to read. A giant with endless worlds. A miniature solar system that challenges everything we thought we knew about our place. As the moons continue their eternal dance, we are reminded of the clockwork precision of the natural universe. We look to the skies not just to see, but to understand. And Jupiter is our greatest teacher. Thank you for joining us on this journey to the King of Planets and its realm of many worlds. If you enjoyed this deep dive into the cosmos, please like and subscribe. This is Dark Sky Dive. Goodbye.